Welcome students to this session. In this session, we will see examples based on. Now, let's take this example. A fair coin is flipped twice. What is the probability of the following events? Now here we have a fair coin. Now what do we mean by whenever they use the word fair? What do we mean by that? Fair coin as in for the coin, there are only two possibilities. One is head and other is tails. We know that. Fair coin as in there are equal chances of both of them appearing. Equal chances of both of them appearing. There is another one word also for it which is called as biased and unbiased. Unbiased as in we are not restricted or we are not choosing any one face only, that we are not using only heads. I am not saying that I want to use only heads or I want to use only tails. No, we are giving equal chances to both heads and tails. So that is what we mean by fair coin, or there is another word also which is called as unbiased. Now a fair coin is flipped twice. What is the probability of the following events? First is getting at least one head, at most one heads, tails twice and no tails. Let's see each of them one by one. First of all, let us find the sample space for flipping a coin twice. Whenever two coins are tossed, the possible outcome would be, just now we have seen that the possible outcome would be heads heads, tails tails, both of the same faces, and last two would be different faces, HT and TH. The total number of possible outcome would be 4. The first question that we have is getting at least one head. Now what do we mean by at least one? At least one as in one or more than or equal to 1. Greater than or equal to 1. Right? Greater than or equal to 1. So we want to find out getting at least one head, from which means from this sample space we want to find out only those possible outcomes which has at least one head, which means minimum one or maximum it could be anything. Maximum for now, here are only 2 coins, so maximum would be only 2. So minimum 1 or greater than 1. So if we see here, we have double H, 2H, 2 heads. Yes, this is what we want, at least 2. So that is included. Then next, tails and tails, TT. Here in this one, there is no head, so we cannot consider this one. Alright. Now next is HT. Yes, one head we have, we can take that. Next is TH. Here also we have one head, we can take that. So for getting at least one head, we have total 3 possible outcomes. Therefore, probability of getting at least one head, the formula would be number of favorable outcomes divided by the total number of outcomes, which is 3 by 4. Now, let's take a look at the second one. Getting at most one head. Now what do we mean by at most one head? One or less than or equal to. We want one head or less than that. We don't want more than one. Which means if we are talking about this possible outcomes, total what is a sample space? I have 2 heads, then I have 2 tails, then TH and HT. This is our sample space. From this sample space, we want at most one head. We want to find out only those possible outcomes which has one head or less than heads. Less as in 0 heads would also work. Yes. Here in the first one we have 2H, double H. We don't want that, right? We want one head or 0 heads, right? Second one, we have TT, right? We can take T. Why? Because there is no heads. Yes, that is also possibility when we talk about at most one, which is 1 or less than 1. Less than 1 is what? 0. So we can consider 0 heads. 0 heads as in no heads. So TT has no heads, so that we can consider. Next, HT, there is one head. We want that, we can take that. Next is TH, there is one head, so that is also one of the possibilities. So the total number of possible outcomes for this would be 3. And when we substitute into the formula, that would be getting at most one head is 3 possible outcomes and total we have is 4. So that is 3 by 4. Now let's take a look at the third one. This is talking about getting tails twice. Let's take the sample space again. This is our sample space. All right. We are talking about getting tails twice. We want tails when they are appearing 2 times, right? Let's see which has 2 tails. Here we have 2 heads, not a possibility. 2 tails, yes, this is a possibility. We want 2 tails. Do we have here? No, we have only single tail, so not a possibility. Next is TH, again same, only one tail, so not a possibility. So the total outcomes for getting tails twice is only 1. So when we substitute into the formula, the favorable outcomes is 1 and the sample space in that we have total 4. So that is 1 divided by 4. Now for the fourth subpart, we have getting no tails. Let me write down our sample space. With that, it becomes easier to observe and check all the possibilities that we have. Yes, getting no tails. We want only those outcomes which does not have any tails. First is heads and heads. Yes, there are no tails, so this is a possibility. Next is tails and tails. There are 2 tails, a big no. Next, HT, there is still one head, not a possibility. In the next one also there is one tails, not a possibility. So there is only one possibility, which is HH, that is there are no heads into it. So only one possible outcome, and the probability would be the number of favorable outcomes that we have, which is 1 only, divided by the sample space, which is 4. So the probability for this event would be 1 by 4. Now let's take this third example. A fair coin is flipped 3 times. All right. Previously what we have seen? We have seen coin flipping only 2 times. In this example, fair coin. Again the word fair, which is unbiased, which means the heads and tails, the 2 possibilities, have equal chances of appearing on the coin. We are not taking bias or anyone's side. All right. A fair coin is flipped 3 times. Alright, and on the 3 times, all the 3 times we have to check what are the possibilities that we get. So make the sample space first of all and then find the probabilities for all of them. Yes, let's see how will we find out the sample space for this one. When 3 coins are tossed, yes, there are 3 coins, first, second, and again third coin. Yes, if on the first coin I have heads, second coin may also I have heads, and in third also heads. So first is this possibility. Then next, what am I doing? I'm changing this H over here, and in that I'm replacing it by T. So one of the possibilities here we have HTH. Similarly, if we go on doing it for each and every of them, right, one possibility would be HHH. Another would be, let's do one thing from the last HH, I'm removing. This is T. Next, again take H, T and T. Alright, then T, T and T. All tails. Next, keep this T as it is, T as it is, and this is heads. Again, T, heads and heads. Now next, heads, heads, heads we have done. Any another possibility that we have left? Have we taken T, H, T? No. Yes. Any another possibility? Double H are done. For H, I guess we have not taken H, T and H. Yes, so how many possibilities do we have? 1, 2, 3, 4, 5, 6, 7 and 8. So total we have 8 possibilities. We have to check that all the 3 coins, all the possibilities, combination of all 3 of them. So there are total 8 possible outcomes. Yes, now let's move on to solving the probabilities. The first probability that we have is getting all heads. Getting all heads includes getting all heads out of them. Let's see how many how many possibilities do we have? All heads. We want to find out only those possibilities where there are all heads. First, triple H. Yes, this is a possibility. Then next, no. Then next again also we have one T. We have twice single T, twice single T, 3 times T, a big no. So only one possibilities for all heads, that is HH and H. Number of favorable outcome is 1. Substitute everything into the formula. Probability of getting all heads is probability of any event equal to number of favorable outcomes divided by the total number of outcomes, which is 1 by 8. Let's see this next one. When 3 coins are tossed, the possible outcomes can be either. These are a sample space. Now let's see the second probability is getting all tails. We have to find out only tails. We want only tails. Getting all tails includes getting all tails. All the 3 of them should be tails. So there would be only one possibility, which is T, T and T. In all of them, we have combination of H and T. There is only one possibilities. It can be only one, that at all the 3 coins we get all the tails. So again, same, just like all heads, we have all tails. So the number of outcomes would be, favorable outcomes would be 1, and substitute everything into the formula. We have the probability as 1 by 8. Let's check the second one. Getting an even number of tails. Alright, what do we want? Even number of tails. That means out of this total 8 possibilities, we want to find out only those possibilities where there are even number of tails. Even number as in the number of tails would be either 2, there should be 2 tails. Next 4, 4 not a possibility because we have only 3 coins tossing. So 4 is not a possibility. So even number of tails. Yes. Let's check the first one. In the first one, how many tails do we have? How many tails do we have? There are 0 tails. Yes, and 0 is an even number. So we can consider that. Yes, we can consider that also. There are no tails. If we check the second one, there is H, H and T. Single head, one head, odd number. Not considered. Here also we have one head, not considered. Next one we have 2 heads, so this can be considered even number. Then next, if we observe this single head, odd number and no possibility. Then next, two tails, yes, this is a possibility. Then two tails, again a possibility. In the last one, we have three tails. Three is an odd number, so this is not a possibility. So for getting an even number of tails, we have the possible outcomes as 4. Therefore, probability of getting an even number of tails is, substitute everything into the formula, 4 by 8, reduce it, we get the answer as 1 by 2. Alright, let's look into this one. Getting more heads than tails, which means the number of heads should be greater than the tails from the possibilities. Let's check the first one. We have 3h here and how many tails? 0. Yes, greater है ना? Heads, number of heads is greater than tails, so we can consider this. Next, in the next one, I have 2 heads and 1 tail. Still, number of heads greater, so we can consider this. Then HTH, yes, we can consider this. If you see this one, HTT, here the number of tails is greater than heads, so not a possibility. The next one, THH, there are 2 heads and 1 tail. Greater, heads are greater, so yes. In the next one, THT, 2 tails, not a possibility. Next one, TTH, again there are 2 tails, not a possibility. In the last one, there are no heads only, so it is a big no. Alright, so how many total do we have? We have 4 total possible outcomes for getting more heads than tails. Alright, substitute into the formula. Number of favorable outcomes is 4 divided by the total number is 8. So after reducing, which is 1 by 2.